let's look at part B of the exercise 20 in this case. So we know that our force vector is the same, the point vector is the same, we always find torque, but in this case our vector is going to be different. So our vector is going to be different. Now, as I said before, this part right here is going to be R naught. This part right here is going to be equals to A vector. And of course, the R naught is a vector. So now, first thing we're going to find is, well, it depends. You can either find the capital R vector or a unit vector. Because remember, our formula is going to be a unit vector times capital R vector times force F. So let's find our A hat vector. So our A hat vector is going to be equals to the A vector over the magnitude of A, which is going to be equals to 2I plus J minus 2K, all times 1 over, then the magnitude, which is going to be equal to 2 squared plus 1 squared plus 2 squared, which is equals to 4 plus 1 plus 4, which is equals to 9. The square root of 9 is equal to 3. So we're gonna have 1/3 of 2I plus J minus 2K. And this is our A unit vector. Now in order to find our R vector instead, we're going to have to do what? Well, if you remember correctly, we're going to have to do our point P minus R naught. Now point P is equals to 3, negative 1, 0, minus R naught, which in our case is 1, 4, 2. So that's going to be equal to 2 minus 5 minus 2. That is our R vector. Now we are simply to do the cross product between R and F. So let me bring everything up so we have a little more space. Try to finish on this page. Okay, so like I said, R vector cross F vector is going to be equals to I direction, J direction, K direction. And then R is equals to 2, negative 5, negative 2. And F, we said, is equals to 2, 0, negative 5. So let's solve this one. We get I, and we get negative 5 times negative 5 minus negative 2 times 0 plus J, and that's going to be equals to negative 2 times 2 minus, we're going to have 2 times negative 5. If I'm correct, 2 times negative 5. Okay, yes. And then we're going to have plus K, that is going to have 2 times 0 minus negative 5 times 2. So here we're going to have in the I direction, we're going to have a 25 minus 0, or plus 0, doesn't matter, plus J, then we're going to have a negative 4 plus 10 plus K, which is going to be equals to 0 plus 10. So we're going to have a 25I, plus 6J plus 10K. And there is our final answer for the cross product. Now we're going to have to multiply everything by the A hat. Capital R times F. Okay, so our A hat is going to be equals to what we found before earlier. So this one right here, copy it and paste it. And then times, we're going to have this vector right here, copy and paste. So let's keep the 1/3 in front. and we're going to have the 2i times the 25i, which makes 50, plus 1j times 6j equals to 6, and then times negative 2 times 10, so negative 20. So we're going to have a 1/3 times 56 minus 20, so 36, which is then equals to 12. So our magnitude is going to be equal to 12, our torque is going to be equal to 12, and the direction is going to be in the direction of a hat. So as we just said, a hat is going to be equal to 1/3 of 2i plus j minus 2k. And this is our answer. No, a hat is found. So that's our final answer. Let me make sure everything is correct. I'm gonna assume so because everything looks good. Yep.